हेलो गाइस, हाउ आर यू? कैसे हैं आप लोग? राइट, वेलकम इन मिशन इसरो. राइट नाउ in the yesterday class we have seen till the Fourier transform and what is the basically idea related to the Fourier transform और कुछ क्वेश्चन हमने डिस्कशन किया, right, which related to. yes Shrivanshi, welcome. right, thank you dear. now if we'll focus, अगर मैं next topic पे हम चलते हैं, right, that is a brief idea about me. My name is Chandan Jha, 9+ year of teaching experience. right, I'm taking communication and networks, conducted more than 200 session, that is motivational session in various engineering colleges including NITs or some IITs. right, and that is the expertise subject for me. My expertise subject, that is called digital circuit, control system, signal system, communication. You all are familiar with this subject, right? now guys, ISRO mock test जो है, they will basically happen, going to be held from 4th of December from 12 PM to 5 of December 12 PM. right, ये सिर्फ 24 आवर के लिए सेशन ऑन होगा और इसकी रजिस्ट्रेशन स्टार्ट हो चुकी है फॉर द इसरो, दैट इज द मेगा मॉक टेस्ट और मेगा मॉक चैलेंज. यू कैन रजिस्टर्ड, राइट, और इसी के वीडियो के लिंक नीचे एक लिंक दिया हुआ है जहां पर आप जाकर इसको रजिस्टर कर सकते हैं. राइट, नाउ just moves on the next topic, that is called, first of all, it is very important, just keep in mind always, for the ISRO exam, there is 45 days is basically remaining, right? Only 45 days is remaining, and for the EC gate, that is 66 days is remaining, right? 66 days is remaining. So guys, जस्ट प्लान योर सेल्फ अकॉर्डिंग टू दिस डे. राइट, ये जो आपके पास दिन दिए गए हैं उसी के हिसाब से आप प्लान करिएगा, सो दैट यू विल गेट मोटिवेटेड एंड यू विल एक्सलरेट योर प्रिपरेशन इफ यू विल कीप इन माइंड दैट इज ओनली द 66 days एंड फॉर द इसरो 45 days इज रिमेनिंग. राइट, एग्जाम से पहले भी क्या होता है, इन द एग्जाम से पहले, जब एग्जाम से एक रात पहले, एग्जाम से एक दिन पहले अगर हम पढ़ाई शुरू करते हैं तो उस रात में हमारा दिमाग कितना तेज चलना लग जाता है. क्यों? क्योंकि हमको पता है कि अगले दिन क्या होने वाला है, पेपर होने वाला है. राइट, सो अगर आप डेडलाइन अपने दिमाग में रखेंगे, डेफिनेटली योर प्रिपरेशन विल गेट एक्सेलरेटेड. राइट, नाउ जस्ट कम्स ऑन द नेक्स्ट टॉपिक, दैट इज कॉल्ड Laplace transform. राइट, दैट इज Laplace transform. वी कैन स्प्लिट. मणि, गुड इवनिंग डियर. राइट, पुनीत, हेलो. श्री लक्ष्मी, हेलो. right, now in the Laplace transform, we can say that we can split the Laplace transform into two parts, in the bilateral Laplace transform and the unilateral Laplace transform. In the bilateral, in the signal system, you mainly deals with the bilateral Laplace transform, and in the mathematics you will mainly deal with the what, unilateral Laplace transform. In the bilateral Laplace transform, नमस्ते दोस्त अनिल कुमार, नमस्ते. राइट, बायलेटरल लैप्लास ट्रांसफॉर्म का जो फॉर्मूला है, दैट इज एफ ऑफ एस इज नथिंग, इट इज जस्ट इंटीग्रेशन ऑफ माइनस इंफिनिटी टू प्लस इंफिनिटी एफ ऑफ टी ई रेज टू पावर माइनस एस टी डी टी. रवि किरण, गुड इवनिंग डियर. राइट, हाउ आर यू? नाउ अगर मैं यूनिलेटरल की बात करूं, right, in the unilateral f of s equal to 0 to infinity f of t e raised to power minus st. So there will be the difference between bilateral and the unilateral. In the bilateral, in the formula, there will be the from minus infinity to plus infinity, and in the unilateral there is only from 0 to infinity. Right, but first of all, we cannot apply directly formula, right, in the any function. First of all, we have to calculate the ROC. Sir, how we will calculate the ROC? For the ROC in the bilateral Laplace transform, we can say that from minus infinity to plus infinity f of t e raised to power minus sigma t mod of dt, that should be a finite value. So we can say that the range of sigma, by this formula we will get the ROC, the range of sigma for which the function will become stable. वो रेंज सिग्मा का जिसके लिए फंक्शन स्टेबल होता है, दैट इज कॉल्ड व्हाट, दैट इज कॉल्ड द आरओसी, रीजन ऑफ कन्वर्जेंस, बिकॉज इट इज मेकिंग द फंक्शन कन्वर्जेंस. राइट, कन्वर्ज्ड. यस, वन क्वेश्चन, देयर इज वन डिफरेंस बिटवीन द यूनिलेटरल, there is one difference between the unilateral and Laplace transform. Yes dear, I'm coming on that difference also. In the bilateral Laplace transform, first of all, before applying this formula, first of all we have to find out. Right, Kiran, Ravi, I am also good. Namaste. Rajshri Day, namaste. Right, now before going to use this formula, that is bilateral Laplace transform, first of all we have to calculate the ROC in the bilateral Laplace transform. if there is the possibilities, or if we'll find some range of sigma for which the function will become stable, then only we can say that the function is converged with the range of the sigma, and we can apply the Fourier Laplace transform formula, that is f of s equal to nothing, it is just a minus infinity to plus infinity f of t e raised to power minus st. But yes, in the unilateral there is no need for the ROC. There is no need of ROC. We can directly apply the formula. So in the mathematics, right, mathematics में हम generally करते क्या है? We are not finding the ROC, right? Because in this case we are just generally using the what? Unilateral Laplace transform. Okay, Puneet sir, what is ROC? ROC is nothing. ROC means the region of convergence. It means it is the basically, first of all, if just take the example, right? Right? Puneet, just take the example. If any function is e raised to power 2 of t u of t, if we'll observe this function, then this function is looking like this, right? Exponentially increasing function in time domain. And we know that we cannot use the Fourier transform of this function. Why we cannot use the Fourier transform? Because function is unstable. So I am not using the Fourier transform of this function, right? Why? Because the function is unstable. Because the Fourier transform is applicable only for the function which is stable and the marginally stable in nature, right? So we are not able to use this. Now, if we want to calculate the Fourier transform of the function, then first of all that function should be stable. So how this function should be stable? Sir, multiply this function with the decreasing function. So I am taking one example like this. That is called e raised to power minus sigma t. Now if we'll multiply this function, then this function will become e raised to power 2t dot u of t into e raised to power minus sigma t. Or we can say that e raised to power 2 minus sigma into t into u of t. Now to make the function stable, the power of that function should be what? Should be negative. So by the u of t we can say that this power is positive. T is positive. So this value should be negative. Why this value should be negative? Because here t is positive just because of u of t, and e raised to power minus, if there is a minus sign, then we can say that function is decreasing, and decreasing function is always stable in nature, right? In this case we can say that. So if 2 minus sigma is less than 0, so we can say that sigma is 0, greater than 0. So if the sigma is greater than 0, that is nothing, it is just a ROC. It means before using the formula, we can say that that is the value sigma for greater than 0. This function, not greater than 0, greater than 2. So we can say that this is the value of sigma. If we are putting the value of sigma greater than 2, then definitely with the multiplication of these two signal will become decreasing signal, and decreasing signal is always stable in nature, right? So if it is stable in nature, then we can say that what? Then we can say that the function is what about okay, then we can say that function is stable in nature, right? That's why that sigma is greater than 2 is a basically condition for which the function will become stable, right? That is the condition of ROC. Yes, sir, is there a shortcut to convert the rectangular into sinc f and sinc f into sinc t into rectangle f? Yes, dear, that is the colorless, okay, colorless element. Yes, there is the possibilities and there is the shortcut also, but at this time I am not dealing with it, but definitely sometime we'll make a lecture on this particular topic, right? There is the shortcut how we'll calculate the rectangular pulse into the sinc function and sinc function into the rectangular function, right? That is called the duality property, right? By the duality property we can convert it, right? So don't worry about that. Sir, why ROC cannot used in the unilateral? Puneet, I'll ask definitely. I'll give you that idea about the ROC, right? Why that ROC is not used in the unilateral. But first of all, अगर मैं इसी topic के ऊपर इतना hang करने लग जाऊँगा, then definitely we'll lost some topic that is very, very important. In this chapter, I am going to discuss about the filter characteristic also, that is FIR and IR. That is very, very important for what? That is very, very important for the ISRO examination, right? Right? Puneet. Okay, but yes, in the rank up course, I have discussed the topic in very much of detail in the both the case, right? Puneet, your question also, why the ROC is not used in the unilateral, it is only used in the bilateral, how the Laplace transform is basically derived from the Fourier transform, everything we have discussed in the rank up class. And yes, colorless element, we also discussed what is the basically shortcut in which the rectangular pulse is converted into the sync pulse and sync pulse is converted into the rectangular pulse. We have discussed this thing in the class, right? So just go through that lecture, you will find it. Now if we'll solve, just listen carefully, that is very very important for you. इस क्वेश्चन के मदद से we'll get all the knowledge related to the Laplace transform and again ROC related to the Laplace transform, right? Okay, find the Laplace transform of this function, that is e raised to power 3t u of t. If we want to find out the Laplace transform, I'm not going to find the shortcut. Yes, definitely. If I want to write the Laplace transform of this function, we can directly say that 1 upon s minus 3 sigma is greater than 3. Definitely we can say that. But at the particular time, I'm just discussing the basic concept behind the Laplace transform, how we can solve that, right? Before solving this function or finding the Laplace transform of this function, first of all, we have to find out the ROC. In the interview, generally, that question will be given. Just find the Laplace transform. Everybody is doing nothing. What? They are just using this one. This one is the Laplace transform. And after the solution, they are writing the ROC. First of all, we have to find out ROC first, then we can apply the formula, right? That is the most important thing, right? Arpit, Laplace transform need not define for this case. Okay, no, dear. In this case, the Laplace transform defined. How we can say that the Laplace transform defined? I'll explain you. Okay, just look at the function. First of all, I'm going to define the ROC. What is the function? Sir, f of t, nothing, it is just a e raised to power 3t u of t. And as we know, at the discussion, we know that if e raised to power having negative value, then that function will become what? It's stable, right? Then only the function will become stable. So just look at the function. For the ROC, the formula is nothing, it is just a minus infinity to plus infinity f of t e raised to power minus sigma t dt should be absolute integrable, right? Should be absolute integrable. Sir, how we can say that? Just find out. Minus infinity to plus infinity e raised to power 3t u of t e raised to power minus sigma t dt should be absolute integrable. By the using of u of t, the limit will become 0 to infinity, because we know that the u of t is defined only between 0 to infinity, right? And the magnitude will be 1. So from 0 to infinity, I'm putting the u of t value 1. So this function will become e raised to power 3t dot e raised to power minus sigma t dt should be less than infinity. Now just observe this function. We can also say that sigma 0 to infinity e raised to power 3 minus sigma into t dt should be absolute integrable. How this function should be absolute integral? Just observe it. What is the value of t? If you will think कि इस t की वैल्यू आएगी क्या? Sir, what is the value of t? तब आप t को देखोगे, लिमिट को ऑब्जर्व करिए. If you will feel limit is nothing, it is just a positive. So what will be the value of t? Sir, t की वैल्यू कुछ भी नहीं. The t will be always positive just because of limit. Limit will give you the idea what is the value of t we are putting after the integration, right? So t is positive. We want to make the function stable. Right? Yes, Ravi, very good. So what about this value? Sir, this value is positive. So hence we can say that this value should be negative, so that the function will become in the e raised to power there will be the negative sign and function will become stable. So 3 minus sigma should be negative. So 3 minus sigma should be negative, so should be less than 0. So here we can say that sigma should be greater than 3. Okay, sir, can we put the equality sign? Just look at. If you'll put the sigma equal to 3, then it will become e raised to power 0. And e raised to power 0 is nothing, it is just a 1. So we have to integrate 1 dt, it will become unstable function. So sir, it is not possible. We cannot put the value of t equal to sigma equal to 3. So ROC is nothing. We can say that ROC is nothing, that is sigma, that is a j omega. It is a rectangular representation. So sigma should be greater than 3. It is the pole at 3. Dash line basically indicate that point is not included. That point is not included, right? Obvious, we can comment on the function causality and the stability also, right? But here I am not going to discuss this topic. Obvious, Ravi Kiran, yes, it is an unstable this function is unstable because it is not using the j omega axis. But yes, ROC exists. What is the ROC? We are seeing only the existence of ROC. Sir, ROC exists, that is sigma is greater than 3. If the ROC exists, then we have to use what? Then we have, sir, इस type of question is asked in this, so definitely. और इससे अलावा भी क्या क्वेश्चन पूछे गए हैं वो भी अपन क्लास के अंदर डिस्कशन करेंगे. टेक आउटसाइड, राइट? Yes, 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 dear. Now we can say that if we find the ROC, after the ROC, it will move the Laplace transform. So what is the formula of Laplace transform? Sir, formula of Laplace transform is nothing. F of s equal to minus infinity to plus infinity f of t e raised to power minus st dt. Now we can say that it will, what about the f of t? Sir, minus infinity to plus infinity e raised to power minus 3t, sorry, plus 3t u of t e raised to power minus st dt. Now minus infinity to, or u of t will become what? 0 to infinity. So we can say that 0 to infinity e raised to power or s minus 3 s minus 3 t minus t, or we can say that 3 minus s into t dt. And if you find the limit, then answer will become 1 upon s minus 3 because it has the minus sign also, right? So it will become s minus 3. Now we can say that it means if you want to find out, this answer is possible only when the function will become what? There is the range of sigma for which the function will become stable, right? Yes, Ravi Kiran, the function is unstable, but we are making the function stable by multiplying e raised to power minus sigma t, right? Now we can say in the ISRO examination, every question is basically for the 3 marks, right? Punit Kumar, every question is the 3 marks. So we can say that e raised to power 3t u of t having the Laplace transform 1 upon s minus 3 sigma is greater than 3. Very easy question, right? Very easy question. Now, next, if we'll move on the jet transform, we can say that jet transform is also split into 2 parts, right? We all are aware about this topic. That's why I'm not going to discuss in very much of the detail about the Laplace transform and as well as for the jet transform. Yes, but we'll do some question related to ISRO which is asked in the ISRO, right? Nikhil Ranjan, Fourier transform is a subset of Laplace transform. Please explain the correlation between them. Okay, Nikhil Ranjan, very good question. निखिल एक्चुअली में टाइम नहीं है पर फिर भी आपने पूछ लिया, डेफिनेटली आई विल एक्सप्लेन इट. व्हाट अबाउट द लैप्लास फोरियर ट्रांसफॉर्म? फोरियर ट्रांसफॉर्म इज नथिंग, इट इज जस्ट ए माइनस इंफिनिटी एफ ऑफ ओमेगा. यस, वन क्वेश्चन विल बी आस्क, मैं सबको बता दूं क्या क्वेश्चन पूछा गया है. द निखिल रंजन विल बी आस्क दैट क्वेश्चन, सर द फोरियर ट्रांसफॉर्म इज अ सबसेट ऑफ द लैप्लास ट्रांसफॉर्म, जस्ट एक्सप्लेन इट, राइट? सो निखिल रंजन, एज ए इंजीनियर आई एम एक्सप्लेनिंग इट in the mathematical terms, not in the theoretical concept. Yes, but we can explain it in the theoretically concept also, right? But right now I am just explaining it with the mathematically. So f of t nothing, it is just a f of Fourier transform nothing, it is just a f of omega minus infinity to plus infinity f of t e raised to power minus j omega t dt. And what about the Laplace transform? In the Laplace transform, in this function f of t, the function should be what? F of t e raised to power minus sigma t. So we can say that minus infinity to plus infinity at the place of f of t, we have to write what? This function. Because in the Laplace transform, there is not only f of t dot e raised to power minus sigma t. Now e raised to power minus j omega t dt. Because we are taking the Fourier transform of what? F of t e raised to power minus sigma t. Now we can say that it is nothing, minus infinity to plus infinity f of t e raised to power minus, taking outside, sigma plus j omega into t dt. I am writing sigma plus j omega as a s. So the function will become minus infinity to plus infinity f of t e raised to power minus st dt. Right? Now we can say that it is nothing, it is just a Laplace transform. It is just a Laplace transform. It is Laplace transform. So sigma is nothing, it is just a damping factor. Just revise the control system. Control system, there will be the zeta. At the place of zeta, I am using here the sigma. Where is the sigma? Sigma. Right? So if we'll see the quickly observe this function, if I am putting the sigma equal to 0 in this function, in the Laplace transform, if sigma equal to 0, in the sigma equal to 0, then the Laplace transform is converted into what? The Fourier transform. So the Laplace transform is a vast tool, but the Fourier transform is a only tool which is used for the sigma equal to 0 only. That is the sigma equal to 0 only. That's why in the control system, you are not using the Fourier transform, right? Anywhere. We are using not only the control system, even in the signaling system also. In the signaling system, not signal system, sorry, in the network also. In everywhere, whenever the frequency domain is required, we will move to the Laplace transform, or we will use to the Laplace transform. Why? Because the Laplace transform is a vast tool in which the sigma may be anything. But in the Fourier transform, sigma should be only 0, right? That's why we can say that the Laplace, and in the any practical system, there is no necessity that the sigma is always 0. That's why in the control system, we are dealing with the many system in which the sigma will be 0, positive, negative, everything, right? So I'm not using here only the Fourier transform. We are using the Laplace transform only. Okay, Nikhil? So Fourier transform is inversely proportional to the Fs of the correct or wrong. Shri Lakshmi, just wait for some time. After that, I'll come to that point also, right? So difference between the absolute stability and conditional stability. Okay, Surya Ganesham definitely will explain this. What is the absolute stability and what is the conditional instability? In the conditional stability, there will be the possibilities for some values at which the function will become unstable. But in the absolute stability, the function is always stable. Always stable for the any values, right? That is the major difference that you will study. Just like the conditional stable, you can say that the marginally stable. If you will feel the marginally stable, why it is called the marginally stable? Because that function is not stable for the every input. That is stable only for the set of the input. But yes, it is possible for the few input, the system will become unstable. That's why it is called conditionally stable, limited stable, marginally stable. But in the absolute stable, whatever the input is applied, but exception, input should be stable. Whatever the input is applied, the function is always, output is always stable. Then that system is called what? Absolute stable, right? Right now, got it, thanks. Okay. Now that is the Z transform. In the Z transform, we can say that in the unilateral also, sigma 0 to infinity f of n z raised to power minus n, and in the bilateral Laplace transform, f of z equal to summation of n equal to minus infinity to plus infinity f of n z raised to power minus. Of course, here we also use to ROC. Sir, how we'll find the ROC? For the ROC, summation of n equal to minus infinity to plus infinity mod of f of n r raised to power minus n should be absolute summable. So in this case, we can say that r, that is the sigma, right, r, radius. So we can say that the range of r for which the function will become absolute summable are called what? It is called the ROC, right? So अगर आपको यहाँ पर ROC find out करना है in the Z transform, you should always follow the one thing, that is the range of r for which the function will become absolute stable are called what? ROC, right? Just look at the question. I'll explain thing with the question, right? Just look at the question. Now I'm going to discuss this topic in very much of detail, this question in very much of detail. That's why that will give the more clarity towards the Z transform to you, right? After this question, we will come on the one question which comes in the ISRO 2015 paper. 2015 में ISRO में question आया था, very easy question, right? So हम they solve करेंगे, right? Now for the Z transform. If the function is nothing, f of n is nothing, it is just a 2 raised to power n u of n. So again, we are not able to use, we cannot use directly the mathematical formula or Z transform formula. First of all, we have to check the whether the function is stable or not. For range of r for which the function will become stable are called the region of convergence. So before using the formula of Z transform, first of all, we have to use the ROC, or we have to find out the ROC, right? What happened to point the Z plane when poles are inverted? Definitely, dear, if the poles are inverted, colorless will explain this topic, right? Don't worry about that, right? First of all, I'm just explaining this topic in very much of detail. I'm not bothered, that topic is not bothered about the answer only, right? What is the answer? क्या आंसर है उससे कोई लेना देना नहीं. आंसर जनरेट कैसे हो रहा है वो चीज मैटर करता है, और हम उसी मैटर के लिए इसको डिस्कशन कर रहे हैं, राइट? नाउ जस्ट लुक एट द फंक्शन. सबसे पहली बात करेंगे किसकी? सर ROC. How will find the ROC? Sir, summation of n equal to minus infinity to plus infinity mod of f of n r raised to power minus n should be less than infinity, so that the value of r for which the function is absolute summable are called ROC, region of convergence, right? Z transform is a replica of the Laplace transform but used to discrete signal. No, that is not a 100% replica. There is some difference also. अगर replica ही होता तो उसकी कोई जरूरत ही नहीं होती. But yes, there is a technique in which the Laplace transform we can convert into the Z transform. That is the basically filter, right? जो आप there is the two type of filter, FIR filter, IR filter. So just focus on one thing that is called time invariance method, right? In the time invariance method, we are nothing. We are just converting the Laplace transformed function into the Z transform, right? That is the basically technique we call time invariant method, right? There are two technique. One is bilinear transformation. Another one is impulse invariant method. We'll discuss this topic in detail right now. सबसे first for the ROC. So if you find the ROC n equal to minus infinity to plus infinity f of n, right? ये topic है. Now if I am putting 2 raised to power n u of n r raised to power minus n mod should be less than infinity. So if u of n will give you the idea that is n equal to 0 to infinity, that is, or we can say that this will become 1, so it will become 2 raised to power 2 by r raised to power n. Now that is the series. If we'll extend this series, then it will become, right, if we'll series 1 plus 2 by r plus 2 by r square plus 2 by r raised to power cube and so on. It is nothing, it is just a GP, right? It is a GP, we can say that, right? आप find कर सकते हैं ये एक GP है. And GP का answer, there is the two possibilities of answer. We cannot write the GP formula directly without knowing the function is summable or not, right? If you are using the formula without knowing the function is summable or not, you are doing the wrong thing, right? आप गलत कर रहे हैं. तो आपको क्या करना चाहिए? First of all, that function should be decreasing order or converging, right? Converging का मतलब stable होना, decrease होते हुए दिखना चाहिए. So just observe this series. Sir, if this series having the value less than 1, 2 by r having the value less than 1, so that point में आएगा, it will comes in the fraction. So in the fraction, square of that fraction value, point की value का, that will again is a very small value. Cube, it will again, it is a very small value. So this will become decreasing function only when 2 by r is less than 1. 2 by r is less than 1, or we can say that r is greater than 2. It is the only possibilities for function will become absolute summable, right? Then only the infinite will become, it will become the less than infinity. What happen when r equal to 1 is placed? अगर मैं r equal to 1 रख दूं तब क्या होगा? अगर r equal to आप 1 रख देते हो, sorry, r equal to अगर मैं 2 रख देता हूं, it will put r equal to 2 in this function. So it will become 1, it will become 1, it will become 1. So we are adding 1 to the infinity value, so it will become infinite, right? If you will add 1 infinite times, then it will become infinite. So we cannot put the equality sign, we cannot use the equality sign, should be less than, so that r should be greater than 2. And it is in the circular format, we know that the mapping, so that is r equal to 2 and ROC will be outward. ROC should be outward. Right? Now if we say that ROC should be outward, now ROC comes, ROC exist कर गया, ROC exist कर गया तो हम use करेंगे what? Then only we'll use the Laplace Z transform formula. What is the formula of Z transform? Sir, f of z is nothing, it is just a n equal to minus infinity to plus infinity f of n z raised to power minus n, right? Now we can say that yes, your answer is Archana, your answer is correct, right? Z upon z minus 2, yes, your correct answer. So if we'll put z n equal to minus infinity to plus infinity 2 raised to power n u of n, z raised to power minus n, summation of n equal to 0 to infinity 2 by z raised to power n. Now it will again become the GP. So 1 plus 2 by z, or we can say that 2z inverse 2 by z plus 2 by z raised to power square, and so on. We know that the mod z value is greater than 2. That's why we are using the formula of Laplace transform 1 of GP 1 upon 1 minus 2z inverse or z upon z minus 1. We are using this formula or applying GP just because we know that we are putting the value r is greater than 2, because r is nothing, it is just a mod z, and z is nothing, it is just a e raised to power j, r e raised to power j omega. So if we will take the mod r, it will become mod z, it will become r only, right? We check the convergent divergence function. Mistake done by Rama Rugojan in one of the series experiments. Yes, there should be. Right now, that is the basically answer, z upon z minus 2, not 1, z minus 2. And what about the ROC? ROC, mod z is greater than 2 or mod r is greater than 2, we can say that. Now just moves on the next question. That is the ISRO question, dear. It is a ISRO question. ISRO में आया हुआ question है, और विल सॉल्व, हमने ये क्वेश्चन क्लास के अंदर भी सॉल्व किया हुआ है, राइट, पहले. सो if we'll discuss the ISRO question, this question, we all are familiar with this. It is nothing, it is just a cos hyperbola and theta. It is the ISRO question, very easy question. You all are remember the formula, cos hyperbolic theta. What is the cos hyperbolic theta? Yes, that is the formula of GP 1 up a upon 1 minus r. Yes, dear, but a is nothing, it is just a 1 in the previous series, right? Now, what about the ISRO? In this question, cos hyperbola n theta is nothing, it is just a e raised to power n theta plus e raised to power minus n theta divided by 2. We don't use here j, because j will be done in the cos theta. Here it is a cos hyperbola theta, right? We know that the cos hyperbola x is nothing, e raised to power x plus e raised to power minus x divided by 2, right? That is the basically function. Yes, one question Suryavanshi asked, sir, in the previous question there will be the causal or anti-causal. Definitely, dear, the function will be causal. If the ROC is outward, then the function will be always causal. If ROC is inward, then that function is not causal, right? And for the stability, if the ROC includes the unity circle, then we can say that the function is stable. Otherwise not, right? Yes, Shivashri, right? Okay, Shivashri, you're correct. Right now, if we'll use this formula, then we can say that u of n having the z transform, nothing, it is just a z upon z minus 1. So e raised to power theta raised to power n u of n, it is nothing, it is just a e raised to power n theta. E raised to power n theta. The same thing. Having z upon z minus e raised to power theta. Now e raised to power minus theta raised to power n u of n. It is nothing, it is just e raised to power minus theta n. So the z transform will be z upon z minus e raised to power minus theta. We all are aware about this, right? Because 2 raised to power n u of n, we have done that thing. There is the 2 raised to power n, that's why the answer will become z upon z minus 1. E raised to power theta raised to power n, then we should write at the place of 2, we have to write e raised to power theta. Now just add it. If you are adding it, then we can say that it will become theta n plus e raised to power minus theta n u of n. On here it will become z upon z minus e raised to power theta plus z upon z minus e raised to power minus theta. We can write like this, right? Now, if you will take z minus e raised to power theta into z minus e raised to power minus theta, then z minus e raised to power minus theta plus z into z minus e raised to power theta. It is like this. Now just multiply it, z square, it will become 2z square. It in the 2z square minus, and taking outside, e raised to power theta minus e raised to power minus theta, not minus, plus theta upon, in this side we can say that z square minus z, here is also z e raised to power theta plus e raised to power minus theta plus 1. So to multiply this side. We have to multiply those two, this side and this side. Now, so this function will become, I am writing this function here, 2z square minus 2z, it is also again cos hyperbola n theta, so n theta not theta, upon z square minus 2z cos hyperbola theta plus 1. Now taking 2 outside, I am taking in the denominator of this function. So the answer will be, it will become cos hyperbola n theta, and the answer will be nothing, it is just a z square minus z cos hyperbola theta upon z square minus 2z cos hyperbola theta plus 1. That is the answer. I think, hope you have done this question in the linearity principle also. Sir, not visible below portion. Okay, dear, just wait. Here is nothing, it is just a e raised to power n theta plus e raised to power minus n theta into u of t. In this question, in this side, there will be 2z square minus 2z cos hyperbola theta upon z square minus 2z cos hyperbola theta plus 1. Taking 2 outside, right? So if we'll take the common, or we are take the 2 common and just divide by this factor, right, from this side to left hand side, then it will become cos hyperbola n theta u of t, u of not t, u of n. It will become z square minus z cos hyperbola theta upon z square minus 2z cos hyperbola theta plus 1. That is the answer, right? Nikhil Ranjan, super sir. Okay, thank you dear, thank you Nirjin, Nikhil, right? Okay, if you'll move, that is the first part. Now, if we'll move on the next part, so just remember this thing. What is the basically what is the formula? So in the minus sign, there will be the minus. Yes, z square minus z. So the answer will be nothing. Z square, z is also taking common. The answer will be a. Right, only a will solve the answer because there is a plus 1 sign. Here it is not a plus 1 sign. That's why the answer will be nothing. It is just a. Right, very easy question. And if you are preparing for the gate, then already you have did this type of question many times, right? So ये question आपके लिए बहुत ही easy लग रहा होगा क्योंकि आप लोग सब aware है इस function से. Yes, one question, sir. Can we say cos and cos hyperbola have the same form of Z-transform? No, dear. How we can say that? In the function, just observe the function. अगर आप question को solve करोगे, then we can say that there will be e raised to power cos theta is nothing, it is just e raised to power j theta plus e raised to power minus j theta divided by 2. But in the hyperbola we are not using the j. So there will be the some difference, right? Cleared easily, sir. Thank you. Okay, Uma, thank you, dear, thank you. Right now, if we move on the next question, or that is in the digital filter, right? Just remember, I'll solve one question. मैं आपको एक question solve करवाऊंगा और you will find, आप जितने भी किताबें चल रही है मार्केट में, you will never see a solution of that question, right? जो ISRO के अंदर 2017 के अंदर question आया हुआ है, that question came in the ISRO 2017. Very important. I'll give you the very short approach to solve that question, right? I'll give you the exact formula also. And after the exact formula, I'll give you the short approach so that the calculation will become very easy. You will see that thing in the next slide, right? Now, if in the digital filter, there are two types. One is the IR filter and another one is the FIR filter. IR filter means the infinite impulse response, and FIR filter is nothing, it is just a finite impulse response, right? Sir, what is the basically it is a digital filter actually, right? Sir, what is the IR filter? Infinite impulse. How we can find that this filter is IR or FIR? हमको कैसे पता चलेगा कि सर ये FIR है कि IR है? नाम से पता चलेगा दोस्त. Just focus on the name. IIR, infinite impulse response. It means the function response you will feel. आप इसके feel करोगे इसके response में. There are infinite number of samples, right? There are infinite number of samples in this FIR, right? So 0 for n less than 0. And not equal to 0 for n is greater than equal to 0, there is the infinite number of sample present. If there is the infinite number of sample will present, then we can say that that filter is FIR filter. And if there is the finite number of sample will present, so we can say that if h of n, okay, 0, that is for less than 0. Negative side में तो होगा नहीं, just because of the causality. In the causal, the function should be present only in the positive side. There should be no negative portion, right? In the causality. So, and not equal to 0 for n from 0 to m minus 1. There, if the sample will present only in the finite interval, then we can say that it is nothing, it is just a FIR filter. So by the observation of the equation, so that the observation of the equation, we can comment whether the function is or system is FIR or IR or FIR. हम comment कर सकते हैं, that is very easily, right? Sir, we want communication system live class for gate. Definitely the communication will also in the plan. So I will discuss the communication, mainly the probability, how to find out the probability of error, and random variable and random process. Generally in the communication I'll take two topics: random variable, random process, and probability of error calculation. I think the most of the student will get feared. They have the fear how to solve the probability of error, random variable and random process का नाम का आते ही उनको डर लगता है. We will solve some question related to gate as well as in the ISRO, and you will find that question is very easy if you have the basic knowledge related to random variable and random process. Okay, one question, sir. After M1, Anil Kumar, yes, one question. After M minus 1 will be 0 or not? Yes. After the M minus 1, the answer will be 0. That's why we can say that sample will present in the finite interval like this. And beyond this value, the answer will be 0 always. It is called FIR, finite impulse response, right? Okay. Now, that is the basic difference. That is the theoretical portion or boring portion also. What is the FIR and IR? But we can predict the one theoretical question in the ES examination, and sometime it will also ask in the ISRO examination, right? So that the basic concept is required about the FIR and IR. Sir, FIR system has the finite duration, we have seen that, and it has the infinite duration, we have seen this, right? Name itself indicate this one. Now, FIR system are non-recursive. Just note down. Sir, what do you mean by recursive? What do you mean by recursive? Just focus on the recursive portion, right? Yes, one question that will be the very helpful. Thank you, sir. योर क्लास इज फेबुलस. ओके, परमजीत दास गुप्ता, दोस्त बहुत बहुत धन्यवाद आपका, थैंक यू वेरी मच. आई ट्राई माई लेवल बेस्ट, कोशिश करता हूँ जितने टाइम में कंसाइज फॉर्म में काम की चीज़ जो है वो मैं आपको डिलीवर कर सकूँ, राइट? आपको ही पता है टाइम बहुत शॉर्ट है. अगर इफ विल टेक वन पोर्शन, जस्ट टेक द लैपलास ट्रांसफॉर्म. इट इज नॉट, आई एम नॉट एबल टू एक्सप्लेन एंटायर लैपलास ट्रांसफॉर्म इवन इन टू 10 or 11 hours, राइट? इट विल टेक अराउंड 15 hours to 16 hours to complete entire Laplace transform. So that is the shortage of time, but in the shortest of time I'll give you the important topic which is very useful for the ISRO examination, right? Okay dear, what do you mean by recursive? Actually generally that question will be asked in the interview. What do you mean by recursive? In the recursive system, just remember one thing. In the recursive system, output of filter or output of the system depends only on the present input as well as the previous input, right? Or present state of input as well as the previous state of input. There is no requirement or there is no relation between previous state of output to the system. मतलब कहने का मतलब इतना है कि सिर्फ इसका इनपुट का प्रेजेंट और पास्ट से रिलेशन होता है, इसका आउटपुट के पास्ट से कोई रिलेशन नहीं होता है, राइट? इन दिस केस. But in the IR filter is called recursive, right? Important topic. The IR filter is called recursive. Why recursive? Because there is a feedback, and if there is a feedback, there will be the relation of input and output also, right? So past output along with the input, present and past input along with that, past output is also depends, right? उसके ऊपर past output के ऊपर भी depend करता है. That's why it is called recursive. It is called non-recursive, right? So दोस्तों इस टॉपिक को थोड़ा ध्यान से रखिएगा. What is recursive? Especially for the interview, right? Especially for the interview, right? One thing more. In this equation, FIR filter का general equation अगर आप observe करेंगे, you will feel for the FIR, finite impulse response, you will feel there is only zeros. There is only zeros, right? There is no poles. That's why FIR system is called only zero system. FIR system is also called only zero system. But in this case, IR, there will be the pole as well as for the zero. That's why we can writing like this. अब आपके दिमाग में एक चल रही होगी खुरापात, क्या कि सर ये तो फाइनाइट लिमिट लगा हुआ है. तो दोस्त ये y ऑफ n का रिलेशन है. अगर आप सिस्टम का रिलेशन लिखोगे, दैट इज y बाय x, output divided by input, right? Then you will feel there will be the pole, there will be zero, and by the series expansion, if you will feel there is the infinite number of samples, right? आप infinite number of sample system के अंदर देखेंगे, right? और infinite number of sample है, तो उसको स्टोर करने के लिए मेमोरी भी कितनी चाहिए? If there is the infinite number of sample, so to store that sample, we required what? Sir, infinite memory element is required actually, right? Infinite memory required. But in this case, we can say that there is only the finite number of sample. If there is the finite number of sample, then we can say that what? Limited or finite memory is required in this case, right? Or in this case. That is the most important, friends. Again, I am just repeating one for the one thing more. Just remember, always remember one thing. Finite sample, infinite sample, recursive FIR, recursive IIR, non-recursive. Zero, only 0%, zero as well as 4%. There is an infinite number of sample, infinite memory. There is finite number of sample, finite memory. Just remember this thing. Okay. One thing more. FIR filter always stable. Always stable. But we cannot guarantee for this system, FIR filter. Because it is the infinite duration, na? If any system is in the finite duration, we can comment the system is always stable because it is finite duration. अगर कोई infinite duration का है तो हम उस पर कमेंट ही नहीं कर पाएंगे क्योंकि हमको पता नहीं चलेगा उसका समीशन हो सकता है अनइनफाइनाइट आ जाए. If their function is split into entire n range, then it is possibility. The summation of that function will become infinite. It is possibilities, right? Yes, one question, Prince Babu. You are great, sir. Thank you so much for your effort. Oh, Prince, thank you, dear, thank you. Right now, इस टॉपिक को ज़्यादा इंपॉर्टेंट नहीं है. ऑल जीरोज मैं बता ही चुका हूँ, ऑल पोल्स, राइट. वन थिंग रिमेंबर, जस्ट इक्वेशन. गेट में एक बार क्वेश्चन भी आया हुआ है, सिर्फ इक्वेशन देके पूछ लिया कि बताओ. In the gate, there is the one question will be asked in this. There will be the one equation. And by the equation, we have to judge whether the system is FIR filter or IR filter. Sir, just write down the example of FIR filter. Y of n equal to 0.5 x of n plus 0.5 x of n minus 1. If you'll feel y z by xz, right? If you'll find out y of x, then there will be 0.5. और आई एम नॉट राइटिंग दिस, यहीं से आप समझ लीजिए y बाय z अपॉन x ऑफ z इक्वल टू 0.5 प्लस 0.5 z इनवर्स. देयर इज द ओनली जीरो इफ यू राइट दिस इक्वेशन इन द z ट्रांसफॉर्म. यू नो दैट x ऑफ n इज नथिंग, इट इज जस्ट ए z इनवर्स इनटू x ऑफ z. x of n it x of z, y of n is y of z. So y of z upon x of z, you will feel 0.5 plus 0.5 z inverse. Only the zero is present, there is no pole. That's why it is FIR. और अगर आप यहां देखोगे, आउटपुट प्रीवियस स्टेट ऑफ इनपुट पे भी डिपेंड कर रहा है. आउटपुट डिपेंड, here the output depends only the input as well as the previous state of what? Input. It is non-recursive. But in this case, we can say that output depends on the previous state of input, a previous state of output. सर रिकर्सिव, इफ इट इज अ रिकर्सिव, इट मीन्स व्हाट? ये अगर रिकर्सिव है तो ये क्या होगा? सर इट इज नथिंग, इट इज जस्ट ए व्हाट? इट इज जस्ट ए IR filter. Yes, one question, Uma. Sir, they ask the question from DFT and FFT. Yes, they will ask a very few question and very interesting question on only the theoretical based question related to f of t and DFT. Actually, the complexity, memory requirement related to that question they will ask, or one will discuss DFT and FFT. हम ये दोनों ही टॉपिक को डिस्कस करेंगे इन वेयर वी विल डिस्कस दिस टॉपिक इन गेट, क्योंकि अभी 2 दिन क्लास ले रहा हूं मैं इसरो का और 2 दिन क्लास लूंगा मैं किसका? गेट का. सो इन द गेट सिलेबस विल डिस्कस मेनली द DFT एंड FFT, राइट? सो दैट द क्लियरिटी, और यू विल गेट द मोर क्लियरिटी रिगार्डिंग टू दैट, राइट? नाउ one question, interesting question from ISRO examination, right? Or that question will be solved only by that student who has the knowledge related to the designing approach only, right? So just observe carefully, right? Today's signal system is last. That is not that signal system is last. We'll see the signal system 2 class in the gate classes also, right? There is the proper schedule. Right, it is not important for ISRO. Yes, it is important here. There is the one question which will ask in the ISRO. That's why I take that example, right? Now, sir, filter design in the next step like y of n plus 1. Dear, actually not possible, because in the y of n plus 1, the function will become non-causal. And we know that the filter is a practical system. So in the practical system, you will feel always delay. That is not in advance. If you are writing y of n plus 1, it means you are advancing the signals. But in the practical system, there is no advance. We can only in the delay, right? That's why you answer. ऐसा नहीं कि पंखा अभी चलने लग जाएगा क्योंकि कल आके कोई बटन दबाएगा, right? Future value पे कोई dependency नहीं होती, right? That's why you will never find y of n plus 1. You will always find y of n minus 1, y of n minus 2 for the practical things, right? System physically, right? That is actually the Nikhil Ranjan will discuss this topic, how the pole will be added in the system as in the separately in the control system, right? हम इसमें भी कर सकते हैं, there is the transformation, right? कर सकते हैं, but अभी मेरे ख्याल से इतना time है नहीं, right? That's why, sorry for that, Nikhil, right? Now, look at the low pass filter. It is nothing, it is just a low pass filter, right? And it is basically the practical low pass filter. In the ideal low pass filter, there will be the sharp cutoff. But in the practical low pass filter, there will be the linear cutoff, or we always want a linear cutoff frequency, right? So in the practical, there will be some overshoot in the pass band also, and there will be some overshoot in the stop band also, right? This value is basically called the edge of pass band frequency. Edge of pass band frequency. This is omega s is called the edge of stop band frequency, right? So just remember these two terms. This is nothing, it is just a corner frequency, or we can say that the edge of the pass band frequency. It is called the edge of the stop band frequency. That's why I'm using omega p or omega s or fp or fs, right? ये overshoot है, it is the middle, जो भी value होगी इसकी, this value is 1 plus delta p and that is 1 minus delta p, right? ये सब क्या है, delta 1 और delta 2, we'll discuss this topic, right? And that is the stop band overshoot, right? That is the turbulence, right? It is called pass band and this is called stop band, right? Now just remember one thing. अब मैंने कुछ term, actually we have used some term that is important, right? What term? Sir, one is G. What about the delta? This delta and FP and FP and FS, right? Or omega P or omega S, right? Now, and yes, one thing more. Difference between these frequency is called basically del F, right? That is transition frequency, right? Del F is nothing, it is just a transition frequency. Just observe now carefully. Just observe carefully. Kiran Kumar, I'll give you the answer of that your question. Just wait for some time, right? Now, they will generally ask about the N. N is nothing, it is just a number of taps. Number of taps. It is not a hypothetical question. That question will be asked in asked in the ISRO, right? That is the question belongs to ISRO. ये ISRO का question का concept है जो मैं आपको समझाने की कोशिश कर रहा हूँ. The number of taps. Sir, what about taps? What is basically the taps? Taps is nothing. It will be the parameter. ये एक parameter है और generally represented by the capital N. It will give the idea how many the memory are basically required to designing the filter. कितनी मेमोरी की रिक्वायरमेंट होती है एक फिल्टर को बनाने के लिए. दूसरी चीज, राइट, इसी के अलावा कॉम्प्लेक्सिटी पैरामीटर भी कितना है वो भी एन ही बताता है. सर, इस पास बैंड की क्या कैरेक्टरिस्टिक है वो भी एन ही बताता है. It means it will show the characteristic of pass band if you know the value of n. The basically the complexity parameter, how many memory are basically or how much memory are basically required to design it, all are basically considered by the n. That's why they will ask the question related to n. Right? For the designing approach, in the practical designing approach, the n number of times is very, very essential, right? So that is the formula to find out the n, right? N. What is that? 2 by 3, 10 log, or 2 by 3, that is not 10, 2 by 3 log 10 base 10 base 1 upon 10 times delta 1 into delta 2 into fs upon del f. Del f is nothing, it is just a transition band, right? We have the transition width like this, del f transition, right? Now what about delta 1? Ripple in pass band, that is the pass band. It is delta p is just one. We have said it is delta p and it is delta s for stop band and pass band ripple fluctuations, right? Now we know that in this formula there is log terms, right? In this term delta 1 and delta 2 will be given in dB. So first of all we have to convert the dB into the normal value, then just replace delta 1 delta 2 and use this formula, and after that possibilities the question will become very complicated. And even by using the formula it is very typical to solve that question without calculator, right? You know that. So just remember one thing, by this formula I have replaced this formula by this one. N number of taps equal to attenuation. A double T E N is nothing, it is just a attenuation factor directly used in dB, right? So no need of the conversion की जरूरत ही नहीं है अगर आप इसको dB में यूज करते हैं. So just use in dB directly without using or without changing the any value, right? Now n number of taps equal to that in the dB 22 into beta t or bt. What is bt? F stop, F step, or F pass. It is nothing, it is just a del f. If you are subtracting, it is del f upon fs is nothing, just a sampling frequency, right? Or attenuation directly put in the dB. So used generally this formula, it is very useful, right? It is very useful. So in taps equal to, again I am repeating that formula, and taps is nothing, it is just a 10 upon 22 into bt. What about bt? Delta f upon fs. What is delta f? Delta f is nothing, it is just a transition frequency, transition bandwidth, and fs nothing, it is just a sampling frequency. So just look at the question. ISRO question, it is nothing, it is just a ISRO question, right? ISRO question, 3 marks question, ISRO. If you want to solve this question, just look at or just read the question. What will be the minimum number of tab required to realize a FIR filter having pass band 10 kHz, F stop 15 kHz, pass दिया हुआ है, stop दिया हुआ है, we can find del f, F pass minus F stop, F stop minus F pass. 15 minus 10, it will become 5 kHz. What about sampling frequency? There will be the sampling frequency 2 kHz, 200 kHz. Again I am repeating the question. What will be the minimum number of tab required to realize a FIR filter having pass band 10 kHz, stop band frequency 15 kHz, 0.1 dB pass band ripple, delta 1, delta p, 60 dB attenuation, and stop band basically given, right? By using the formula, just solve it. So forget about the first formula, use second one. What is the second one? If you want to find out the second one formula, sir, n taps is nothing, 10 upon 22 into bt. N equal to attenuation factor in dB upon 22 into bt. So we can say that if you use A double T and attenuation into Fs upon 22 into del f, because Ft nothing, it is just a del f into Fs. So if you want to calculate, just use the A10. A10 is nothing, it is just a 60. Use in dB directly, right? Do not change the values, just directly put the value of 60, that is 60. B answer will be given by the colorless element. Your answer is wrong, dear, just listen. Fs is nothing, it is just a 200 upon 22 into, what about del f? Del f is nothing, it is just a 5 kHz. So if you want to find out, solve this question, you will feel that is 109 point something you will feel, and directly it is approximately equal to 110. It is directly equal to what? Yes, answer. Shri Lakshmi, your answer is correct. A option is basically the correct option. So चीजें easy है, चीजें टफ नहीं है, बट यू हैव टू गो थ्रू द डेप्थ, राइट? बेसिक मैं ऐसा मानता हूं, यू ऑल आर रिमेंबर, यू ऑल हैव द आइडिया रिलेटेड टू बेसिक थिंग. जस्ट एक्सटेंड योर नॉलेज. यस उमा, योर आंसर इज ऑल्सो करेक्ट. Shubhashri, your answer is correct, right? Correct. Very good. Sir, how to find the value of attenuation? The attenuation value is directly given. That is 60 dB. We have to use directly here. No need to find out the attenuation factor. Directly it is given, right? 60 dB, right? Prince Babu. So it is the basically all about the classes we have done. मुझे डिजाइनिंग भी बताना था, right? In the FR filter, IR filter, there are two methods for the FIR filter. Just remember one thing. I'm just explaining it right now. If we'll move on the IR filter, there are two methods to design. One is impulse invariant method. Impulse invariant method. Another one is bilinear transformation. Just go through that topic. Transformation. And if for the FIR, there is the windowing technique. Just remember rectangular windowing. Second one is Kaiser window. Third one is Hamming window. And fourth one is Hanning. 0.5 wala Hanning window. So just go through this four topic here and two topic there, then you will get the more confidence regarding to the FIR. Due to the shortage of time, मैं इस चीज को कवर नहीं कर पाया, that's why sorry for that, but definitely if I'll get the time, I'll take that topic again, right? Till that we can say that. Okay dear, so that is the basically all about the class, and tomorrow you will see the control system part 1, right? Now our 100-day crash course course is basically going on, right? That is the green card. अगर आप टेस्ट सीरीज ज्वाइन करना चाहते हैं, there is the 399 for the 12 month, and 1 month, that is 249 for the 1 month, right? And yes, there is a 50% discount is also in this session, right? That's why I'm saying this thing, right? So thank you very much. अच्छे तरीके से पढ़िए, मेहनत करिए, और ज़बरदस्त तरीके से यूँ समझ लीजिए जैसे ही एग्जाम आपका आएगा इन जनवरी और फरवरी के अंदर आपको ज्वाइन करना है इसरो. अपने दिमाग में रखिएगा, साइंटिस्ट बनना है, किसी भी हालत में बनना है, दिन रात एक कर दीजिए, राइट? सोचने की जरूरत नहीं कि जिंदगी में क्या होगा, जो होगा अच्छा होगा. जिंदगी बड़ी छोटी है, अच्छे से यूटिलाइज करिए. अभी हमारे हाथ में है क्या? सिर्फ हमारे हाथ में मेहनत करना है. तो रिजल्ट की टेंशन मत लीजिए, क्या होगा क्या नहीं होगा, हमारे हाथ में मेहनत करना है. 100% अपना दीजिए, हर चीज आपके कदमों में होगा जो चीज आप चाहेंगे, राइट? टिल दैट, थैंक यू वेरी मच. ऑल द वेरी बेस्ट डियर, ऑल द वेरी बेस्ट.